To evaluate this integral using integration by parts, usually we try to let u be something so that, as we take derivatives of u, it eventually turns closer and closer to just a constant, get rid of some variables. And you can try that for this problem, but you'll actually run into a bit of a jam. We're going to let u be natural log 6x, the only other choice. And that means dv has to be 7x. That way we fully substitute, just like the formula for integration by parts says. So let's start plugging things into the formula for the integration by parts. It's u times v, so we got natural log 6x times our v, which we don't have yet, but we can get v by considering the antiderivative, 7/2 x squared. Right, that way when you take a derivative, the 2 would come down, cancel out with a 2 in the denominator, leaves us with v. So v is 7/2x squared. We got our u, we've got our v. Now we need to subtract that by the integral of v du, which we don't have yet, but we can get. The derivative of natural log of 6x is 1/6x, but then times the derivative of the innermost function. So you can see the 6's will cancel out. It's just 1/x. And so that works out nicely because now we're just going to have a polynomial to integrate, and that obeys the power rule, right? The kind of reverse power rule of derivatives. So let's clean this up. I'm just going to put the constant out front, natural log 6x times x squared, and I guess you could write x squared over here too. And we're subtracting that by factor out the constant. X squared times 1/x leaves us with just x. So that's a nice, easy antiderivative. So we got 7/2 x squared over 2, then plus some constant c, right? Because whenever we evaluate an indefinite integral, there's an infinite amount of different functions, because of that constant c that we lose when we take that derivative. So 1/2 times 1/2 makes 1/4 on bottom here. This is 7x over 4. That's how we can finish simplifying this answer. But I think that's everything. If you take a derivative, that should turn back into 7x natural log 6x.